In this video, we will work on our first SmartPy smart contract. We will talk about basic types, arithmetic operations, strings, tuples, and we will also introduce the concept of storage and entry points. And finally, we will talk about the difference between Python code and generated code in SmartPy. So our most basic smart contract in SmartPy is a contract that just stores a number and doesn't do anything else. And to create a SmartPy smart contract, we start by defining a class that inherits from sp.contract. And we can see here that sp is the name we give to the SmartPy library within the rest of the code. And in the constructor of this class, we initialize the storage by calling self.init. And we pass as parameter the initial value of that storage. This gives us our first valid contract, a contract that stores a number, 42, and doesn't do anything else. We cannot even change the value of that number. If we want to have a contract that does something, we need to add an entry point. An entry point is a method of the class with an sp.entryPoint decorator right before it. And the method takes as parameter the instance of the object itself. And we can, for example, access to the storage using self.data and change its value. So here we have an entry point that increments the value of the storage. So plus equals 1 means we take the current value and we add 1. One thing to keep in mind if you're not familiar with Python is that in Python, therefore in SmartPy, the code indentation is important. So whenever you open a block, for example, you create a class, all of the content of the class is the content that is indented by a given number of space or tabulations. So here, all of the content is indented by 4 spaces. And inside an entry point, for example, all of the content is indented again by 4 spaces. As soon as you stop indenting, that means you reach the end of that block. Once we have a contract in SmartPy, we can test it right away by adding some test scenario at the end of the contract. And we will be able to run this code in the IDE and then test it and see how it works. So to create a test, we create a test function and we add a decorator sp.addTest, and we pass as a parameter to this decorator the name of the test. Within the test, we will create an instance of the contract that we call C1, then create a scenario for this contract using sp.testScenario. We add the contract to the scenario, and then we can make a number of calls to entry points. And this will basically initiate the contract, call the entry point, and show us the result. We can see it in the SmartPy IDE. We can run the contract by clicking here, and then we just wait a little bit, and we see the result. We have different sections, one for each call, basically. So here we have a call that corresponds to the origination of the contract, where we can see that the initial value of the storage is 42, the code that was deployed is this, and then we can see the first call to a contract, where we see that after the call to the contract, the new storage is 43, and you can see here which entry point was called, how much the balance of the contract is, etc. So you have a nice HTML visualization of the execution of your test and the impact on the storage of the contract. So SmartPy is based on Python, but one thing we really need to keep in mind when we write smart contracts using SmartPy is that SmartPy is a library, but we're not writing our smart contract in Python. What we are doing is generating a smart contract. So when we run the Python program, this program generates a smart contract. And the fact that we are generating a smart contract has quite a few implications in how we need to think when we write our program. So for example, if we look at this contract, we can see here that we multiply 6 by 7, but the contract itself that we will be generating will never compute 6 times 7. 6 times 7 is computed during the execution of the Python code, which will generate a contract that will contain directly the number 42. Basically, the increment function in the contract that we generate will simply add 42 to the storage. It will not compute 6 times 7. If we want the contract to compute 6 times 7, we need to explicitly generate code that computes 6 times 7. When we write sp.int of 6, this says generate the number 6 in the contract, and here we generate the number 7 in the contract. And when we multiply those two expressions, then this will generate a multiplication in the code of the contract. So this contract will actually compute 6 times 7 in the contract itself, whereas this one will do the computation during the generation, during the execution of the Python code, and will include the number 42 directly in the contract. So sp.int of 6 means generate the integer 6. We saw that we can use sp.int to generate an integer, but most of the time it is not necessary to specify that we want to generate a value in the smart contract. So if you had just written this, where we have the number 42 that we add to the storage, automatically the number 42 will be generated in the contract. So this produces exactly the same contract as this, where we explicitly say that we want to generate the integer 42. This is done internally using overloading of operators. So it can detect that on the left side you have a SmartPy object, therefore we should generate a SmartPy contract object for the number 42 as well. So we saw that we can manipulate numbers, but in SmartPy and more generally in Tezos contracts, we can manipulate 3 types of numbers. We can manipulate integers that can be positive or negative. For example, sp.int of 42 or sp.int of negative 34. But we can also manipulate numbers that are naturals. So these are non-negative numbers. For example, sp.nat of 18. But we cannot have sp.nat of minus 34. And finally, we have Tez that represent a whole number of Tezos tokens. And we can write sp.tez of 12. Or if we want to manipulate small values, we can express millions of Tez. So for example, s.newTez of 12 millions is equivalent to sp.tez of 12. It's important to really understand that int can hold negative values, while nat can only hold non-negative values. Both of them have infinite precision in the sense that they can store values that are large as we want, like up to billions and billions, with no limits other than the available storage. And for int, this is the same for negative values, that can be as negative as we want. Another thing to keep in mind is that Tezos purposely doesn't support floating point arithmetic values. And for example, we can write sp.tez of 0.34, but this is not a decimal number. This is just another way to write sp.mutez of 340,000. We have arithmetic operators in SmartPy expressions, and they are almost the same as in Python. We can use additions, subtractions, multiplications. If you use division, we have to be careful that this is an integer division, since we don't have floating point values. And using 2 slashes is also an integer division, just like in Python. And we can use sp.ediv of 2 values, which returns a pair that contains the result of the integer division of this value by this value. And the second value in the pair is the remainder of that division. Finally, we can have shorthand operators, such as multiply equal, and this is equivalent to g equals g times 2, and the same with subtraction, addition, etc. Now let's work on a contract that has 2 values in the storage. We can store multiple values in the storage by giving a name to each of them. And so when we call self.init, we can pass between the parentheses a list of values with the name, equal, and the initial value. And we separate them with commas. When we do that, the storage becomes a record, and we will see in detail what a record means, but all we have to remember for now is that we can access to each of those values by writing self.data. And the name of the value in the storage. We can also have parameters for the entry points, and for example, we can have an entry point increment both that will increment both of these values by a certain values passed as a parameter. So here we have 2 parameters after the self parameter, which are inc1 and inc2, and we can add inc1 to the first value in the storage, then add inc2 to the second value in the storage. And when we call it in the test, we will write c1 dot, the name of the entry point, and then in parentheses, we give the name of each property, equal, and the value that we want to pass as parameters to this function. Another type that we can use in Tezos smart contracts is the string type, which we can formally write as sp.tstring. So strings are basically text that we can write between double quotes, or we can explicitly write sp.string of the string to say that we want to generate this string within the smart contract. We can then concatenate multiple strings using the plus operator. And so, for example, we can concatenate the word hello, a space, and the word world. And again, if we didn't explicitly say that we want this to be generated in the contract, the concatenation would happen during the generation rather than during the execution of the contract. Be careful, in Tezos, accented characters are not supported. Only non-extended ASCII characters are supported. So if you add an accent, it won't work.